welcome, Nick. Can you introduce yourself and tell us about the Science and Technology Society and how Coastwise got started?
Okay, Mike, thank you very much for giving us the opportunity to talk about what we're doing. My name is Nick Barbie. I was at one time material science the scientist. Then I got into making instruments because the first instrument I worked on was a scanning electron microscope and EDS X-ray detector. And we were one of the first to do that. So the story of my life was I became an instrument maker. So that's one connection with STELLA that we have right off the bat. I'm still involved in selling hyperspectral imaging cameras to museums. And it's more or less a part-time job, but it's we sell Vernier cameras, V-SWIR cameras, and SWIR cameras, and extended SWIR cameras. So there's a whole range, and they typically cost from 40,000 to 140,000, and which is another reason Stella is so attractive at $200 a unit. So I'm still involved in that, but predominantly retired. And I started the Science and Technology Society about 3 years ago now, 2.5 years. And we're initially it was to hold technology meetings and socializing with people that were in science for their careers or just interested in science. And then we just got organically interested in STEM education. And actually, that's where we've been focusing most of our time these days. And the first course, because of my experience, we chose to use the STELLA Q2, which is a 18-channel Vernier spectrometer. And, since I made spectrometers most of my life, various types, and sold them if I wasn't making them, and teaching people how to use them, it was a natural for me to want to do that. One of the most important spectroscopy, one of the most important features of Sarasota and Manatee counties in Southwest Florida, where we're based, are the wetlands. And it's an interface between the ocean and the land, and a lot of neat environmental and ecosystem things happen in wetlands. So we thought we would use a spectrometer to see if we could differentiate one type of plant from another, and in so doing, learn about the importance of wetlands. So there was an ulterior motive. Whenever you have an instrument, you need an application. And so we were sneaking in the interest in the exposure to the application, along with talking about spectroscopy, electromagnetic radiation, how to use a spectrometer, data collection, data processing, all that kind of thing. But at the same time, getting speakers to talk about our environment, the ecological system, the importance of wetlands, the damaging of wetlands that's due to hurricanes and also development. Hurricanes, they seem to survive, development, they don't, which is, somehow hurricanes, because they're natural, do somehow work themselves out. Maybe later I'll tell you a story about that. But so we're now focusing very much on STEM education for students and trying to do something exciting and different. And NASA, with the family of Stella Instruments, has provided us that opportunity.
Awesome. Thank you very much. That was a heck of an introduction. And you actually answered probably like 3 or 4 of the questions doing that.
Okay. Short interview.
Yeah.
Okay.
All right, exactly. So Tara, again, thanks for joining us. And what's your background and how did you get involved with this program?
Sure. Thanks for having me. So my name is Tara Bergstrom Marino. I officially work for Bank of America in technology. I studied computer engineering, but I spent most of my career overseeing a suite of applications and change across those applications. About 8 years ago, 9 years ago, I became heavily involved in STEM with the youth in our community, mostly resulting, as a result of my kids. They were very, especially Michael, was very interested in STEM, and there was really not a lot in our community for him to kind of develop that interest. We, by chance, kind of came into a program called FIRST, for inspiration and recognition of science and technology. We did not have any sort of presence of that organization in our community, but it was at that time the age group that my kids were in was Lego based, and so they really wanted to kind of pursue a team in there. So Michael will share, but he, I told him if you wanted to do that, I would help, but I wanted him to kind of find a team. It could be about 10 members. And so he aggressively went and sought out a bunch of students and came with 60 students. So we ended up having 66 teams because we didn't want to turn anybody away. And we did that for quite some time. But that when we published that, it caught the interest of Lakewood Ranch proper. And so they're the #1 selling master plan community in the nation. And there's, a lot of organization that goes behind making sure that it continues to be the #1 master plan community. And so they do a lot of activities and events there. So they were like, oh, well, what is your vision to bring STEM to the community for our youth? I was like, I don't have a vision. Like, I didn't really have a vision. But they're like, well, we really want to bring STEM. And there's like this very significant demand in our community. And we think, it's obviously an up and coming area. So that ended up, I started, kind of like what Dr. Barbie's doing, but more for youth. I started running meetings and presentations and connecting them with the experts. And I started running Math 24 leagues, and we were running all sorts of, we were running the STEM tent at the farmer's market. And we were doing all sorts of things. When COVID happened, a lot of that went away. Just because everything was locked down and we weren't able to go anywhere. But I remained very engaged in FIRST with Michael and Natalie's team. We continued that. They continued even running activities over the Lakewood Ranch Facebook page. So like STEM activities, we would give every week, we would give a STEM challenge out to the students to kind of keep them engaged and connected, because that was, an isolating time, I think, for our young folks. So we did that. But when we came out of COVID, I knew I was going to be moving away from Lakewood Ranch just because my kids were going to be going to a school that was about 45 minutes south of it. So I didn't want to revigor all of that. When I moved down here, though, I got connected with the Suncoast Science Center, the Fab Lab, which is about 15 minutes from my house. And that's where I met Dr. Barbie. And I was like, oh, well, Dr. Barbie has a vision that was kind of like what Lakewood Ranch wanted to do. And so I said, I'd love to support you in your vision instead of, trying to restart that again. And that's how we became connected. And then he's, brought a lot of great programs to the students and fully supportive. And Coastwise has definitely been a staple of that. And I think it's taught the kids a lot. I don't think any of those kids even knew what spectrometers were before that. So I think, it's been an amazing opportunity. The kids have been involved in it for 2 years now. And I'm just, I really just connect Dr. Barbie with the students, and we have a great relationship doing that.
Excellent. Yeah, Michael, we're glad to have you. In the student perspective, what grade are you in, and what made you want to do Coastwise this summer?
And don't say your mother made you do it.
So I'm in 12th right now, so I'm a senior. And 2 years ago, when it was my mom that brought up the opportunity to do Coastwise, I was actually very intrigued in it, and I shared that with a bunch of other people that I knew. We were all in the same robotics team, so we shared that common interest in trying to learn new things. So I originally approached it with like oh, this is just going to be something new to learn, like something I can just add to my skill set. And then going to the meetings made me realize that this was actually something that was very important um, to uh, I want to say the area, but like the environment, I guess, and helping the wetlands and understanding how their health, how they thrive, how to preserve them. And I actually got very invested in it the more that I started going to these meetings. Um, so yeah, I mean, I think it was a great opportunity. I think it was definitely a very great uh, chance to learn um, some new skills and learn a lot about the environment, how it works, how to measure certain things, how to predict the future of those environments, and to help preserve the Everglades for the future.
I do want to thank Tara and Michael. Our first uh, group, I contacted Tara and I said, Tara, I don't know how to get kids into this. And she said, don't worry, the robotics team will be there for you. So our first group was almost completely the robotics team. So I think not only Tara and Michael and Natalie and all the people, but the just the spirit, the community spirit they have, and the love of STEM courses and efforts and experiences and so forth. So it was really critical to us. So I want to thank them for that.
Before the summer, have you ever heard of spectroscopy or worked with these particular types of scientific instruments?
Um, no, and that was sorry, I'll look at the camera. Um, no, so before I ever got involved in Stella, I had never heard of any of that terminology before in my entire life, and that's I think part of the reason that me and all my other teammates were so intrigued was because even though we are so invested in commonly use STEM instruments and are looking at these innovative solutions quite often, that this was a brand new branch that we had never even seen before. So becoming involved in it was, branching into new territory, and I think that's what originally caught us all and got us engaged into Stella.
What made this program appealing for your kids to participate in? So, what excited you about the program?
Oh, sorry. When the students were younger and they were part of the Lego branch, that program included an innovation project. So every year they were asked to look at a challenge and find a real world solution for that challenge. And that was always like one of their favorite parts. Beyond just the robot part, really the innovation project was one of their favorite parts. But for the league they're at now, when they're doing this level of robotics, there is no innovation project. There's no real world kind of presentation or innovation kind of component. So when Dr. Barbie brought this to the community and was like, hey, I have this Coastwise plan. We're going to be using spectrometry. We're going to be looking at the Everglades and the wetlands, and we want to understand if we can utilize this tool to actually do something in the real world. I knew that the kids would be interested in that, right? It's something that has an impact in the real world, right? That they get to work alongside experts, getting to work alongside you and Dr. Barbie and people that have, real knowledge, I think is invaluable to students to get to kind of work alongside real engineers and real scientists, to kind of see their thought process, just learn from them, like how they grow, how they work through problems, I think is invaluable. And then, also the impact of being able to have the potential of doing something that truly has an effect on the wetlands, I think is an incredible experience, right? Like who wouldn't want a student to be part of that?
Did working with Stella lead you and the students to discover various NASA data sources and stuff you didn't know about before? And what did you find?
Yes, Mike, I think mostly, I have to give credit to Craig Phillips, who really dove into the NASA applications and pointed out to me and to others who were interested in this that there's some phenomenal data sources. We went up and visited a professor at USF who has access to all the, the direct satellite data and some high resolution satellite data. And Craig pointed out the benefits of pace. He Craig was the type of scientist who kept getting ahead of everybody, instead of keeping pace. He was out at the next level already. Unfortunately, Craig and his wife moved back to Colorado. They're not much. It's hard to get them involved, although hopefully we'll get them involved remotely as time goes on. So we one of the things that we tried to do was show how you could use Google Earth and get the aerial images and look at the changes to the vegetation over time, and pointed out the similarity with Landsat and the PACE, which is the ocean sat essentially, is extremely interesting to us. The reason we couldn't use more of the data itself is that it's pretty complicated, very large to deal with, and so forth. So for our first course, which was just 4 days long, we pointed out the similarity between what NASA is doing with Landsat and what we're trying to do. And this year, I think we're actually going to achieve a drone flying, possibly of STELLA itself, but certainly of the nature that Bianca Cilento has done, where in her case, I believe, Mike, she had a spectroscopic drone and then sort of matched up the STELLA 18-channel information with the 3-channel spectroscopic drone, so that they could say this spectrum from the drone gives us this spectrum from STELLA. So now we can look in more detail and do false color imaging. And I think false color imaging is an interesting concept for young students as well. So this year we're fortunate enough, if all goes well, to have a student who, for his science project, designed the control system for a drone, hardware and software. We have a student that might be able to help be not only a student but be an instructor in some sense. And then if we had our own control system, we have more options to modify it and link the flight of the drone with the collection of the spectrum and so forth. So the goal is to get more involved in directly relating our work to NASA's database, and you guys done. It just needs more than 4 days to really delve into that. Yeah, definitely. That's what we're trying to do. And probably said better than I tried to say it, but it seems so out of reach with the Landsat data, other satellite data, and the imagery, that if you can say this is basically how it's done, it's just more sophisticated and a tad more expensive than what we're trying to do. So, but the concept is very similar. So that exactly is the point. Mike, we tried to get the NASA people like you and Paul talking to us. And by the way, that was one of the things the students pointed out as a highlight of especially when they started talking to you about the design of the packaging for STELLA. And that was very interesting, give and take. We were very impressed with the support you gave us and the credibility that you gave us, listening to our ideas and telling us why they're good or why they might not work in a specific case. So I don't know. What do you think, Michael? I think that basically that was, we didn't do much in the way of really introducing you to the archive data of NASA, just because it was pretty deep in its scope for the short time that we had.
So before Coastwise, did you know that NASA monitors Earth's environment from space at all?
I was not aware to the extent that they do, but I was aware that that they have observational satellites, I guess, that do keep track of that.
Oh, well, now that you know more about the satellites, did the Stella help you understand a bit more of the concepts that they use to collect Earth data? Okay.
Yeah, definitely, and that's the concepts, yes, as well as the type of technology that they're using, and as well as like the extent to which NASA can take notes and record data on the environment, given how direct Stella is.
I know it was a 4-day course, but do you think it gave them a new perspective on, say, NASA Earth observations?
Yeah, I think when I first brought this to at least the students that I spoke to, and the first year we predominantly did the robotics team, and then the second year we went to some school students as well that I know are engaged in STEM because we had a bit more time. The common answer back was, doesn't NASA just do like rocket ships? Like what is this, and like what do they do? And I think just learning that there's so much more to what NASA does, and that they actually work on instruments, and that they're doing educational things, and they engage with the students, and they're doing research, I think was eye-opening for the students, right? But I agree with Dr. Barbie then that then saying you're going to get to work with a NASA instrument immediately was exciting to the students, right? Like, oh, we're going to work with something that NASA made, like we're working with something that's really must be like forward looking. So I think that was very exciting. But I think at a very basic level, just having an understanding that NASA is more than just launching rocket ships was important, right? And I think now they're engaged, like, oh, what else does NASA do, right? That kind of like created a spark to like, is there other things that NASA works on, and like what other kind of research programs do they do? And so I think that was kind of like a linchpin for them to kind of start looking at that NASA does more than just launch rocket ships.
Excellent. And then what surprised you about the connections between this local project and, say, NASA's broader Earth science work?
Yeah, I mean, I think any large company should work on a model like this, right? Where you're engaging, something that's kind of cheap and accessible to as many people as possible. You can get students engaged. I have found that students, especially younger students, have such creative minds, and they think so outside the box that you really want them to be engaged in projects like this, that they can really look at problems in ways that we haven't been taught yet, to like, this is the process you follow to look at a problem. Students just kind of look at it however they want with their mind wide open. So I think engaging students in this and making it accessible to them with kind of a less expensive tool set then can help maybe guide, your overarching real modeling and things, because you really do never know what can come out of a student's mindset. I know for us several years ago, we were looking at space travel and the challenges that exist in space travel, and our students came up with this whole suit that had like resistant bands to kind of keep muscles engaged so that they wouldn't lose bone density and all of that. And I think maybe like 5 years later, that was like a real product. Like now people actually use that for physical therapy and things. So, but it's just, it was incredible that 10-year-olds came up with that concept. Like, right off the bat, within a couple hours, like, oh, this is, these are the challenges, and like, this is what we could do. So I think, they having youth and students engaged in real world challenges like this, they can look at it in a different way, and they might come up with ideas that, some of us that have been doing this for many years wouldn't come up with.
Okay. I was gonna say something, Mike, if I'm still allowed a minute.
No, we don't want to hear from you. So,
no, your comment was about linking it to the NASA data inspired me a little bit, because we are talking about doing a freshman and college level course that would actually be a semester, trimester, whatever it works out to be. And in that course, that's where we could really spend a lot more time on that kind of association. A, it makes it a much higher level course, and B, we got the time to do it. So I think that that's a perfect sort of vertical addition. We want to do things laterally in this course across the different instrumentation that you're doing or different applications of the same instrument, but also vertically about the science behind it and then the use of the data further beyond it. So hopefully that's something we're working on now and may come to fruition in a year or two. Not sure, but it elevated the importance of what we're doing to say that NASA on a much larger scale is doing this, doing it at a much more scientific level, a worldwide level, and a zillion applications of it, depending upon which area of the world people are interested in. And so it gave it a substantially a stronger rationale and credibility in terms of what we're trying to do. I think one of the really interesting things was the NDVI, the numerical difference vegetative index.
Normalized difference vegetation.
Normalized difference vegetative index.
NASA is acronyms.
Yeah. And the fact that is something that is universally used, and we can use it ourselves. We didn't take advantage too much of the information the NDVI has given us, but in our drone flying, I think we will use that significantly. And the fact that it's accepted by NASA, accepted by scientists all over the world, and we even had our local waterkeeper who is doing a flyover of using spectroscopic drones, 5 of them, to map the mangroves in the area, and uses the imaging to give you an estimate of the volume of mangroves, and the NDVI to give you an estimate of the health of the mangroves. And then that will become a baseline against which we can monitor the health and quantity of mangroves going forward in future years. And the idea is not just to monitor them, the idea is to find out if there's problems and fix them. This is an organization that fights for the mangroves, so it's not just an exercise. And then I think our first use of drone flying will be for mangroves, because we can tie it directly to the data that the Suncoast Waterkeeper is gathering with, professional pilots, 5 spectroscopic drones that cost $5,000 each or something, sophisticated data analysis. And here we can do a relatively small mini version of the same kind of thing. So yeah, I think all of this has lent credibility from what we're doing on a small scale to what the Waterkeeper is doing on a much larger regional scale, and to what NASA is doing on a worldwide scale. We made a kind of a classic mistake and not fully doing the build prior to the teaching exercise. So, it has the trappings of looking very easy. And yet there's some experience level things that you need to gain. The other thing that caused us a problem was just ordering parts and finding out that they weren't available on the notice that we had given ourselves. And because of that, we had to modify a part. We essentially had to build a part that came as an integrated unit into from two pieces. And that piece ended up not being of the proper dimension for the slot in the housing. So that caused the case not to close properly, and we didn't realize it until we spent hours on it. So it was not, I think the conclusion was it would be nice to have a little more room in there for those wires. And also some suggestions about the placement of the buttons and that kind of thing. But by and large, the problem that we experienced while building was mostly of our own doing. And now we have we have a couple of, I will show you right here. I just got delivered a new Q2. So, yeah, so, we, even though we understand it was needed to be, the design goal was to be small, we didn't think it had to be quite as small as it was, and that we could have used a little more leeway with the wires. Although the problem was not itself the wires, the problem was in the oversized component that we had to rig up from because the part wasn't available directly. So on time. Later they all came in, but they didn't come in on time. We then had the students do a failure analysis on the whole thing. And a couple of the students, including Tara's daughter, Natalie, and Colton, who was an exceptionally young man, the two of them together really led the failure analysis and came up with some great suggestions, some of which were solving a problem that didn't exist, as I said, but nevertheless, we didn't know that at the time. And but the exercise of going through that and then listening to Paul explain why things were done a certain way, why he didn't think our recommendations were necessary in some cases, but also why he thought they were very good recommendations in other cases. That was a great moment for us.
Yeah, in fact, he sent you all a failure analysis report.
Yes, he did.
Right.
Yep.
So I was there for that, and I do recall him stopping the students and really having them explain what they meant and why and all that. I thought it was
yeah, not only the students but the instructors as well.
Yeah, well, and I thought it was incredibly brilliant. The just again how professional the students were and how professional Paul was, and just because you're getting feedback that you don't always want to hear, but you're trying to figure out, of course, why it went wrong. And I think on every end it was handled so professionally, and I think it was such a fantastic exercise,
Yeah.
if nothing else.
I have a saying, Mike, that I used a good part of my life, and that it's not what happens, it's what happens next. So if you run into failures, that happens, but now what do you do? And I think our group and the kids drove it really, and saying, let's dig into this and let's see what we can recommend. And we said, yeah, go for it. And that is a case that took a negative and turned it right into a positive.
I think that this is the most impactful kind of component of any sort of project like this. And I tell Dr. Barbie about that for other things that he looks at doing as well. So, students nowadays are expected to go into college with an understanding of what they want to do, and they need to have dove deep into that, right? They were expected to have done research on it. They expected to have done projects on it. There's a very different bar, I think, being held to students on knowing what they want their careers to be. And I think for students to be able to do that, they need to be able to engage with folks that do the job themselves. And there's not a lot of opportunity for that, right? I mean, as much as maybe Michael wants to be a mechanical engineer without being able to see what that actually means, like what does a mechanical engineer do every day? How is he supposed to know he was really going to want to do that? How are you supposed to know that you want to be an architect? How are you supposed to know that you want to do scientific data analysis if you've never actually been able to work alongside someone that does that with a real data set, normalize the data, put a model against it, understand the impact of that, and have to do the hard work, right? Not just the fun work. So I think being able to struggle, and I agree with Dr. Barbie, sometimes the challenges or the problems or the struggles are much bigger learning opportunities than successes. So I think, for them, Coastwise and Stella provides them an opportunity to utilize a tool in a way that gives them information and experiences they wouldn't have. I think then being able to work alongside real scientists and folks that built the instrument or people that use the instrument and hearing how they use it connects them to real world experiences and gives them an understanding of like how they could what their careers could be like someday, and if that would be interesting to them. And I think overall it gives them a breadth of exposure to things that they may never have known to consider in their careers. I feel like a lot of times students are like, okay, I want to be a lawyer, or I want to be a doctor, or I want to be an engineer, because those are things that they see all the time in movies or they hear about. But things like spectrometry, like things that they've never heard of before. How is a student going to say like, hey, I really would like to study the mangroves and wet groves with like some instrument I never heard of? They're not, right? So unless you give them exposure to that, you're not going to have students that want to go and study that and become experts in it. And
Right.
I think it's important.
We've had this conversation in our ambassador meeting to some extent, but I feel that FIRST Robotics is an ideal model for STELLA people to follow. And the very good thing about it, in my opinion, is that they attract different students. Engineers like Michael's an exceptional mechanical designer at such a young age, and encoders who can do amazing things writing code. Those people are certainly very much attracted to the robotics group. But a lot of the kids that are going to be chemists or geologists or ecologists or data processing people don't have the same skills. And the fact that NASA builds the instruments and they have to figure out how to use them, how to apply them to real world situations, how to collect data, how to process data, how to draw conclusions from their data. They learn about standard deviation, data analytics, and so forth. Data collection, data processing, two different things. And so this is maybe as an exciting opportunity for the people more oriented in those kind of studies who would not be suitable or that sort of useful and building electromechanical device, and so they're very common, very similar in what they teach, and it's not just the STEM, it's also how to interact with the community and how to explain your results to people. And Tara and her groups, she's she's founder of a new robotics club called Ultronic now. And she regards the interaction with people and the community as strongly as the building of the robot itself. And we want the same thing, that same model into our STELLA competitions, should they ever materialize, where you would give a final a seminar to, live stream, explaining the results, explaining the conclusions, explaining the recommendations for next year's program, how to do it better, and hopefully teach some of the community about what's happening to the wetlands, what we can do with our oceans, and how community data can help NASA make some of their more global decisions.
What was it like when your classmates presented the technical problems to NASA's design team?
It was a very positive experience. Paul was very accepting and obviously took notes of all of our feedback and made sure to feel like our input was going to be used to better the product. He also gave us a lot of insight into how his process worked in developing Stella, and I think at that time would have been V2 Stella as well. So it was a positive experience because we felt like we were now part of the progress that we were seeing in Stella, as well as getting a little bit of insight into what was going on behind the scenes.
For Tara, were you present for that particularly?
I was not present for that,
Okay.
but I did hear the presentation, and I did see the output of Paul's remarks. So we do a lot of things like that. As Dr. Barbie said, first his whole slogan is more than robots. So they often require us to engage with engineers and experts and present ideas. And you were just talking about cost benefit analysis. We have to do that. We also have to do analyses on risk versus reward. They have to do decision tree analysis, all those sort of things, and then you have to present them to judges of expert judges to kind of share like why they made certain decisions and how they were. So I feel like this was just another taste of that for them. I know Colton and Natalie worked on kind of their presentation with the rest of the students, but it was an opportunity for them to, share their experience with a professional, which is a skill set, right? To kind of share good and areas of improvement that they see, and then have to defend why they think a certain thing, or why they felt a certain way about something. So I think, that can be hard for a student and even as an adult. So I think, no matter what, those sort of opportunities are really educational and valuable to students. And then I think, as engineers and as adults, to hear from students is also allowing us to help them better their skill set. So I think the students learned a lot. I hope, I think Paul also hopefully took some takeaways from it. I don't think, I know there were some things that were necessarily actually wrong or complicated or a challenge. And it was something else like the chip we bought or something. But I think, hopefully there was some other value in what they presented. But I think anytime you're having a student engage with a real professional and you're connecting them, I think there's a lot of growth.
The data collection portion was actually very simple and very straightforward. We set up multiple plants outside, and we did a series of measurements on each plant. So it wasn't just one measurement per plant, it was a couple. And then we imported that data into, I think it might have been Excel. And we analyzed it. I personally don't remember doing any analysis. I don't think I was part of the group that did the analysis, because there was a portion of the course that I couldn't attend to because I had something else going on. But I think Nick can talk more about how the analysis portion of the course went.
Quick question though for you, Michael. Did you have to measure any kind of reflective surface to normalize the data? So like a white panel?
Yeah. So we did that first, and then we went through with our measurements, and I'm pretty sure we also took measurements of the same white panel between plants, if I'm not wrong.
And now,
Yes.
now I gave you a bit of a hint, but do you know why you did that?
Because I think it had something to do with like normalizing the data we were collecting from the plants. I'm not 100% sure.
And when I say
Or
normalize,
using
it
that
was
as like a
in-
reference point for our data that we collect on the plant.
Okay, yeah, very good.
Yeah, basically, we want to account for the change in sunlight that's hitting the plant. So, whatever
Right.
we're reflecting back is going to be proportional to what's hitting it in some way.
Right.
So
Yeah.
we need
Okay.
to
I
kind of
remember that now.
compensate for that.
I remember
Yeah.
that now. Yes.
So for Michael, what new skills do you learn that you hadn't before, and how do you think it might change what you want to study or do for a career?
It definitely gave me a lot more insight into how data collection is actually done. Before then, I had really only collected data like um, with like single variable like experiments, not with something that had this many components to it that we had to account for, like the sunlight, which is one that I didn't even remember until Nick mentioned it. Like the position of the sunlight changes obviously over time. And like that's not something that I'm used to accounting for. Like working with that many variables was definitely something that was new to me. And although it didn't like Stella itself didn't change the direction of mechanical engineering that I wanted to go into, it definitely gave me a lot more insight into like how the collection of data might actually happen in my field, rather than just like, oh, we're gonna run this tiny little experiment. It might be like, okay, we're gonna run this experiment. Here's are all the variables we have to take into consideration. And I think having gone through the Stella program, although it was short, gave me a little more insight into how that process and data connection, collection, and analysis might actually work.
Yeah. I mean, I think that Coastwise allow them to connect with a technology and a terminology that they never would have had, right? In terms they never would have had. They got to program in a way that's very different, right? So right now they only program for hardware. So they only do hardware programming. They don't do any programming over a data set to like kind of analyze data. That was something that they had never done before. A lot of them had never looked at data set that needed to be normalized before. So what, at least in my team, a lot of the data we look at is test data. So we're testing a singular component for efficiency and effectiveness. And so it's a very simple data set. It doesn't need normalization. So that kind of terminology had never been utilized before, and they never seen a data set that was that large before. As Michael discussed, like the amount of variables they were looking at was also much more complex than something that we would look at in robotics. I think that the data component was something that is a new skill for them. I think just working with a spectrometer was definitely a new skill for them. I think understanding kind of how they would have to present information, and how they could utilize information, and also like how data can be manipulated to kind of not maybe necessarily always give the truth, was also something that was unique to them through Coastwise. So I think those were all very unique skills that they didn't have exposure to before, and without going through the Coastwise program with Stella, they wouldn't have had access to.
Just to show, again, I wanted to mention the Fab Lab that was so generous and crucial to our pulling the first couple of years off. And then here is Natalie, Michael's sister, and there's Michael. So I wanted to show some results of our spectra from the black mangrove, the red mangrove, and the white mangrove. And now these were all obviously saplings, but we knew exactly what they were, and we could get color wise they're all very similar. Here we can see the spectra that we were getting from these. And here's the wavelength axis from 400 to 1,000 nanometers, the reflectance. and these were areas of some differentiation that I pointed out on the spectra that clearly allowed us to differentiate, one spectrum from another. And there are plenty of regions that give us differentiation. And then here's the color bar where the black is infrared and the rest is as shown here. So I think this seemed to be consistent. Consistency is always an issue, but I think it's very interesting that the green color was very common, and these were done 1, 2, 3. So there was no time difference. The sun was at the same angle essentially throughout the whole thing. We used the white card, and so there's clearly differences between this, especially when you look at the infrared here, but also just in the colors. I mean, the spectrometer pointed out some very different levels of color, amounts of blue and green and orange and so forth, that it was hard to see by the eye. And then here we have 7 plants that we looked at, and I'm going to jump to just looking at the 5 green plants. I took out, if you see here, I threw in a couple of ringers because I knew they were going to be quite different in their visible light spectrum because their color is different. And so these were the 5 green plants, and then these were the 2 that I threw in to make sure we got some differences. And so if you go to the 5 plants, you can see that these are all normalized at an orange color. And so all these plants, all these spectra are made to be equal at 580 nanometers. And then you can see there's ratio differences that can be, if consistent, can be used to distinguish one plant from another. Now here's a situation between 2 groups where we looked at the group called Viper and the group called Crocs. And we saw the green box here, which is below. And these spectra between the 2 groups were very similar, remarkably so. Maybe this one, they're all 3 very, very good. So this is the bougainvillea, the jasmine, and the Persian shield. And so 2 different groups doing 2 different spectrometers being used. And then the blue box up here was pretty good match from one group to another. And then finally the heliconia was really not so good of a match. We would have to do a lot more data collection. So but of the group we looked at, we had some pretty good consistency. And this will end up being the true test as to how consistent we'll be able to get. So is the deviation from time to time, group to group, system to system, greater than the inherent deviation of the spectrum? If it is, then we're in trouble. If not, then we're in good shape. So this is part of the research aspect of what we're trying to do. But I wanted just to go back to the mangroves, and this is a very critical application for us, and it's what we'll try to start with in looking at our drone flying, and see if by flying the drone over we can tell the difference between a red, white, and black mangrove, which would be very useful in practice because, sorting out their location, are they in the water, are they by the water, are they partially by the water, which distinguishes one type from another, is pretty hard to do from the air. And so this will directly help possibly the waterkeeper group that's doing this in a more professional and more expensive way. So I just wanted to give you some of the results that let you see kind of the results we're getting. They were, as Michael said, all done in Excel. And next year we hope to and by the way, Justin's science project is using Python for all of these his graphs, which we hope to get to uh, next year. But this year I was I was the one doing the final data plotting and so forth. Although the kids did all the data collection, my skill set sort of stopped at Excel. So that's what I use.
Yeah, I mean, I think if we're going to expand it to more areas, there needs to be sort of like a curriculum guide. And I don't know if that exists, but something that allows someone maybe that doesn't have a Dr. Barbie that's utilized this sort of technology before, that's going to be able to explain it, right? So if you're going to want somebody else like a me to be able to run a course like this, or like a Fab Lab, to be able to run and utilize Stella, there needs to be some sort of instruction set that says like, okay, day one, this is what you want to do. Day two, this is what you want to do. Day three. And maybe there's multiple variations of that depending on the duration that you're going to work with the technology with. So that would be like what I would suggest if we want to expand, right? There just needs to be some sort of high level explanation and instructions so that you can make it accessible to people that don't have a Dr. Barbie that has experience with instruments like this. In terms of what I would say to parents, I would say the same thing I say whenever your students have exposure. The greatest thing that you can do for your kids is to give them exposure to as many things as possible so that they can identify what they want to do in their future with as much information as possible. I think being able to work on something that's real, that could have such a huge impact in the real world is value add. I think being able to work alongside scientists and especially engineers or scientists from NASA, like who gets to do that, I think is an amazing opportunity that every parent should want their children to have. I think anything that you're doing to give your students a growth mindset and ability to learn something new is always time well spent.
If a friend asked you what you did this summer, how would you describe it? What would you tell other students about why they should consider doing something like Coastwise?
I would tell them I learned a little bit more about the Everglades, how measuring data is how data is collected, why it's important to collect data, how that data is implemented into analysis tools, so that you can understand the environment around you. I would tell them about what I understand about Stella now, the program itself. And I'll tell them that it's a great opportunity to get involved in Stella, not to just better yourself and your skills, but to better understand why the Everglades and the environment around us is so important to maintain and preserve for the future.
In your view, why does it matter that NASA makes instruments like Stella available for community science and workforce development? And
Yes.
what do you want people to understand about what you're building here in Sarasota?
I will say, we talked a lot about the FIRST robotics because it is the epitome of STEM competitions and development of kids, both from an engineering point of view and from a professional point of view. And I think Stella instruments are the greatest thing to happen, the most significant innovation to happen in STEM education since robotics. That is a lot of instruments. And who operates these instruments? It is a different group of people than the engineers who build robots, right? This is, many of the kids interested in geology and environmental chemistry, data processing, math students, they may not be skilled in building robotics and electromechanical devices and so forth, maybe scared of them. Maybe they will become skilled in it later, but maybe that seems overwhelming to them. And here's a chance to build, I mean, talk about jobs. There's in $50 billion worth of instruments, there's maybe 500,000 instruments out there. Somebody's got to run them with the technical and scientific bent and understanding. But mostly my experience is those people are not instrument builders. They are scientists more interested in the results, and they don't care so much how it acquired that result. They just want to get the result. So this opens up a possible competition for the competition is more of like a result than a key factor. The key factor is that you have a real science program, hands-on science program that could become the equivalent of FIRST Robotics that brings in more kids than really robotics can bring in. If you limit robotics and you say, okay, it's electrical engineers, mechanical engineers, and coders predominantly. Now, there are other people that come in and help and do the community involvement and so forth. Not saying that there aren't those kind of people or kids, but if young kids think they want to be involved in botany or biology or whatever it might be, certainly ecology, astronomy, all of these different avenues, the data processing, the data collection, the data processing, the interpretation, the culling of the results from a massive amount of data, figuring out what's important, what isn't, what the trends are, and then explaining this to people who may not be as knowledgeable as you in this area is a tremendous opportunity for kids to have at a young age. And it may strongly affect their careers. As Michael said, he was a mechanical engineer from day one. He knew that's what he was going to be. There was nothing that was going to change that. Uh, but, those of us that like science, I was started out in chemistry. I knew I wasn't going to be a mechanical engineer, electronic engineer. I ended up in material science, and I ended up using instruments and then making instruments most of my life. And I had no idea when I was in high school that this was even a remote possibility. So what this allows us to do is get kids, not necessarily engineers or coders, into this realm of really hands-on science, competitive science. If we do some competitions, something very significant. So this is why I'm so excited about STELLA. I know that even in college, I used instruments, but never had any kind of training in it. Never had any kind of training in data collection. I mean, it was all self-taught, if you will. So if we get kids at an early age who can latch onto this and say, I love this kind of stuff. This is what I want to do. In the earlier age we can affect them, the better.
What do you want people to understand about what you're building here in Sarasota?
In the bigger picture, we want to make Sarasota a first-rate location for tech-savvy families, parents, kids. And the way to do that is to make sure there are opportunities. And so we want to build the technical community, the technical strength of the community, make it a place where technical families and their companies can feel comfortable locating, startups can locate. One of the best things we can do in my position is to have opportunities for their kids, and opportunities that can be modeled nationwide and worldwide. So if we can say that a program that is now worldwide began in Sarasota and Manatee counties in Florida, that would make people aware of the things that we're doing. So um, uh, that's what it does for the area. It would do. Uh, we can't. We're not going to change much of the the political spectrum or the funding spectrum, or we're not going to do much of that. But if we can make it a known place for starting really advanced STEM education programs for kids that get national and international recognition, to me that is a phenomenal contribution.
Finally, any closing thoughts about where you want to take this program and why people should support it?
One of the things we're doing next month is we're having some kids that, one of the, besides Coastwise, the very big program we do is send kids to Italy for 3 weeks at a AI session at Fondazione Bruno Kessler, which is in Trento, Italy. And they pay 100% of the fees once the kids get to Italy. So what we do and what the parents do now is the parents have to have the money to send a kid to Italy. And so we would like to open this up more for other kids that may not be able to buy the airfare, whose family may not be able to buy the airfare to send them over. Even though it doesn't cost them anything when they get over there, the airfare is not cheap. So we are trying to say that we give a technical experience that kids can't get anywhere else. It helps the career opportunities decision by opening up. If kids have a bent towards science, but never heard of instruments, never heard of spectroscopy, don't know anything about data analysis at grades, at say rising freshman level, where they're just going from 8th grade to freshman. This is the time really to hit those kids with, look at these opportunities. So it will help the standard of living. As I say, draw more people into the community that are tech aware people and are worried about their kids' education. And then we have this international tie, which is an experience that opens up all new kinds of opportunities for kids. They meet friends from not only Italy, but from there's many countries represented in this program. So next year, we're going to be able to send 6 or 7 kids to this program. We've been upgraded because of the level of kids that we've been able to send. But we want to expand that international collaboration. And we want Italian kids to come here, and we want more of our kids to go to Italy. And all of this, builds the community, builds opportunities for kids, brings in families that are concerned about that, and so we can make kids aware of the environmental issues, of the effective development, so they can make their own decisions. And this is our Coastwise program about whether development is a good thing or whether it's nonsense. They can look at images. They can compare images before and after. They can see mangroves decreasing in volume or changing in normalized difference vegetative index. And then we could expand this to water quality, agricultural analyses, sustainable farming, air quality to a lesser extent. We're fortunate enough not to have severe air quality issues here because of the ocean and the breezes and all that kind of thing. So, but the things that care about the community, it teaches the kids not only science, but uh, more about the environment in which they live and how what the real difference is between a organically grown product and an organic soil versus non-organic, and help them understand the choices that they make throughout life. Part of it is you've got to realize that, I mean, again, here I'm explaining that when tech companies look at locations, they do look at what's available for their children, for their families and the children of their families. And some places in Florida, like the East Coast, where the launches are done and so forth, can be Jacksonville is a pretty industrial area, but we're noted for our beauty, and so environment becomes a big issue. But we want to also have tech companies, new companies, startups, or relocations of companies here, and we have to show them that there's some amazing informal STEM education programs, and maybe even other education programs, not so necessarily STEM oriented, entrepreneurial things, which we're looking into, an entrepreneurial fair, for example. And so this is to make the area a more prime location for tech families and tech companies to locate. Yeah,
Thank you
no,
so much.
you've been great. I'm really pleased and happy you guys were able to join us today. Thank you.
Well, again, anytime we're going to get to interact with, real experts and hear feedback, I'm going to sign my kids up for that.
Excellent.
Yeah, even after surgery.
Yeah,
All
Michael,
right,
get
so
on there.
we'll see you tonight at this.
That was an emergency. Like I didn't know that was going to happen until Monday. So I didn't actually sign him up, like knowing that was going to be the case. Thank you so
Awesome.
much, Mike, for all that you do and engaging with students and your time. I mean, it really has been an amazing opportunity. I look forward to seeing what comes out of it this summer. But I know, not just Michael, but all the students, they really, really enjoyed the summer. They really enjoyed being able to speak to you and to Paul. I know that was, as Dr. Barbie said, he didn't really just say that like to throw like it really was the highlight. They all talked about it for weeks.
Awesome.
About how they got to talk to NASA. They thought it was the coolest thing. So, I definitely, appreciate you guys taking the time, making it a memorable experience for them, listening to them, taking their feedback, making them feel part of, a process, making them feel part of a solution and part of, impacting something that's beyond themselves. I think that was a really inspiring moment for them. So thank you for that. And Dr. Barbie, always, thank you for making all the opportunities for students and in the community. It's awesome to work with you.
Yeah, well, thank you, and right back at you, Tara. Thank you very much. Mike, can I take the moment to give my particular thank you to a couple of other people? I mentioned Craig Phillips, who's been wonderful for us and really jumpstart everything we were doing, because he could immediately see the value of the NASA data and help the rest of us to understand that there's a direct link between what we're trying to do and what NASA is doing on a sophisticated scale. And the Faulhaber Fab Lab, the Suncoast Faulhaber Fab Lab, has donated their space to us while we were doing this program and their equipment. And they were just a wonderful host for us, and we couldn't have done it without them. And then I did want to mention Tim Childers, who was our building manager, if you will, ordered the parts, tried to get the instructions into the students' hands, and gave some lectures in the process. And he will be with us again next year, and hopefully we'll add one or two more instructors to our group. But the Fab Lab, Tim and Craig have done a great job for us. And of course, I can't thank Tara enough, but I think I already have.